Once again, welcome one and all to our great session for the webinar for today's session. The topic, as discussed, it will be 10 factors influencing chemical anchoring system. Today's speaker, myself, Mr. Dinesh Ajay Kumar, Senior Field Engineer for UAE, and my colleague, Mr. Omar Al Jazari, Senior Field Engineer for Saudi Arabia. A very brief introduction about myself. Having an experience around 1.5 years in education department and more than 5 years in fixing, which is Fischer fixing, specialized in design of chemical, mechanical and nylon angers. And also we do sort of training of angers, installation system and fire stop. My education background is Masters of Engineering from Civil Engineering, Computer Data Structural Engineer. Those are some of external certification which I've done throughout my career, and some awards and recognition for myself.
Welcome also from my side. My name is Omar Al Jazairi. I am a technical engineer for Saudi Arabia. I have around 1.5 years work in Fischer company as a technical engineer. I worked before in Bitco for pre-stressed concrete technology around 2 years, and I work as in a consultant office as a structural designer around 1 year. I am specialized in anchor design, steel aluminum design, the experience software, and we will see it in this presentation. Also, we made the proposal for the fire stop and selection. We made seminar and webinar, and we made the link between the Fischer product and major trades and the solving technical problems. I am professional as a civil engineer. Let's go to the other slide. This slide shows the time split. The duration of the webinar is around 45 minutes. After that, there is a question and answer session around 10 minutes. At any time, at any point of time during the presentation, you can put your question in the question box, and we will answer it after finishing the 45 minutes. And we have the pull and feedback session around 5 minutes, which is must, because from your opinion, we can get our improve. Let's go to the other slide. For better experience, we recommend to use only internet. Don't use the Internet Explorer, use Google Chrome. Please do not parallel download to make smoothly streaming. The question will be answered at the end. All answer would be mailed if we cannot answer it now. We will talk with this is small introduction about the Fischer brand. Fischer is a German company. We have around 49 subsidiaries around the world. Fischer founded in 1948 and distributed around more than 100 countries. We have more than 4,600 global workforce. And the important thing, we have over 1,500 international patents, and we sell around over than 4,000 article number. This is some fact numbers. 71 is the years young German company Fischer. 10 is the factors worldwide that distributed over the world. More than 4,000 global employees that we have, more than 30,000 number of items manufactured daily, 850 million euro global turnover, and the Fischer UAE, this one of the subsidiaries, is founded in 2006. So this is the distribution of our subsidiaries. One of this is Fischer Middle East. And the Fischer Middle East support many countries: Kuwait, Bahrain, Qatar, UAE, Pakistan, Oman, Saudi Arabia, Ethiopia, Kenya, and Tanzania. So this is a small introduction about the Fischer. Let's start the webinar. Dinesh, you have the stage.
Thank you for the great words, Mr. Omar. So let's get into our topic in detail. So before getting into the detail, let me ask you a simple question. Why do you think that the chemical angle is having that much importance in influencing? Could I have some opinions from you guys? You can have your replies on the chat box. As said, It's very simple that we always require look for an economical solution. So first of all, it's like economical solution. At the same time, the selection of a chemical anchor should be an appropriate one because there are different base materials available right now in the market. So the chemical anchor should be for the right base material. Then the quality assurance, which is the most important thing in Middle East market, because the quality should be assured that it has got the capacity to take the load, or it can be used in the surfaces where we are providing. At the same thing, safety installation. All these points will be taken care once we cover the 10 factors of influences. And last but not the least, the valid approvals. Here I start with my topic where we will be discussing 10 factors, first 5 by myself and rest 5 by my colleague, Mr. Omar. Different system, bond strength, curing and gelling time, installation steps and accessories, drill hole condition. So let's start with the different system. As you are all aware that the chemical can be packed in different types, and here are some of the type of packing. First one, sausage or cartridge type, solid cartridge, bucket or can system, or glass capsules or foil capsules. So how does it differ? Like what is the point like when we have different type of packaging? Yes, in chemical, it plays a vital role. Coming to the next slide, it is well explained what would be the difference or how can it be differ. First of all, the shelf life. The shelf life for a solid cartridge, which Fischer produces, is of having 36 months. At the same time, for the foil cartridge, it's 18 months. When you compare with foil capsules and glass capsules, it's again showing a great difference. So this is where the packing have its own importance. At the same time, if you're using a cartridge or foil, if the labels or if workmanship is not using properly, there are chances that it can break. But solid has got its own sustainability to stay, even though you are using or even though you're misusing it. The last but not the least, but the important or where we can save the chemical is on the scaling, where we can see in solid cartridge, as explained for Fischer product, there is a scale on the cartridge itself so that there will be no wastage in your site. But in foil, it will not be in the cartridge, but it can have in a dispenser gun or may not have. At the same time, in can system, no waste. And also foil capsules or glass capsules is having no wastage because it comes in a cylinder image as shown in the above picture, previous image. Once we cover about the packaging, the next important thing is the chemical compounds being used. This is very familiar because one and all knows like there are different chemical compounds in the market such as polyester, vinyl ester and silan and epoxy. So what does this polyester place? Like it is one of the most economical solution that can be used in masonry and also for non-cracked concrete application. But what happens is that when you use the polyester in a concrete surface for a great time, a saponification effect may happen over there. At the same time, if you are using a vinyl ester, it's an economical solution for both for masonry as well as for cracked or non-cracked application. And it can be used for post-installed rebar application too. The next one, the vinyl ester and silan. It's highest performing vinyl ester based product. But when you compare for a vinyl ester in a masonry application, it's not that economical because there are cases where you require quite good load and you want something where you don't find a solution with vinyl ester. Over there only we will propose for masonry vinyl ester and silan type. The best product in the Middle East market is epoxy. As everyone knows, there are few points that make epoxy hit in this market. We will be discussing those points also why epoxy plays a major role in the market. As you all know, epoxy has got highest performance chemical in the market with where it can be used for a cracked as well as for a non-cracked application, also for post-installed rebar application, and also for higher depths. Now, here comes the second most important part, which is known as bond strength. I'm sure everyone in the market in the civil engineering terms have heard about bond strength. As the term defines, it is the most important factor in chemical anchoring and this is how it differs from product to product. This is the strength of the chemical, where there's a perfect bond between chemical angle and the substrate. Force with the chemical angle can take per millimeter square area is known as bond factor. Here you can see the equation, the denotation of bond, which is mentioned as tau RKC, and NRKP is the pull-out capacity which angle can give, and A bond means area of bond. And this is the equation how we will find the pull-out capacity which angle can give. Very simple, with the bond factoring into area of bond. As said previously, how does approvals play a role in products? Because when we get an approval such as ETA, which is known as European Technical Assessment, it means that the product is being checked in various stages or various steps, and it has been classified. Over here, you can see one of our products, ETA, where it is showing the tau value, which is our bond value. And these are the bond values for different type of diameters. So once you get the bond value, and once we know pi into d into h effective, where d is the diameter and h effective is the anchorage depth. Over here, it is simply multiplied to find the pull-out capacity of an angle, which says bond, which is 9, multiplied by pi, multiplied by the die, and multiplied by the h effective, and it's around 61.07 kilonewton. So this is how the bond strength plays an important role in each chemical. Now the next is the most common term wherever you heard, because once you have a chemical in your site, or once you have a chemical being used, there will be two terms mainly known as curing and gelling time. So what does that means? Let's say a gelling time, in one word we can say it's an open time, or initial curing time, or working time. In simple words, once you have made a hole in the substrate, you have opened your product, you have fixed your static mixer. Once the hardener and resin comes through the static mixer, the gelling time starts. So the gelling time can be different for different chemicals. It will not be the same. It depends upon the components. Like last we discussed, there is polyester, there is vinyl ester and silan, there is epoxy. So the gelling time also differs for each product. As said, once the motor and hardener mix, the gelling time starts. Now moving to the curing time. Once you have fixed your rod where you are having gelling time, that means that you have time to adjust the rod. Where in curing time, once you have done the gelling time process and all the installation, it requires a time to get cured. That chemical needs to get a perfect bonding between the substrate and the chemical you are using, chemical rod you are using. Once the curing time is done, you have time to give the required load to that angle. Now, here is a very interesting question for you guys. Let's see that you have, a chemical. I mean, your installation by installer was done properly. It means that he has taken care of gelling time, and your project is in a bit hurry, and you have done the curing time, but not up to 100%. You have done curing time only about 80%. What will be the load, or how much load you can consider from that? Can I have some answers in my chat box? I hope the question is clear, that once the installation is done, there is a curing time required, but the installer has waited only for 80%, 80% of time. He has not completed 100%. And then he has started applying load. What happens? Whether you will get full load, whether there is no load, or whether it will be 80% of load, or whether it will be half the load. How much load he can assure in that fixing? I request some answers to be given in chat, so that half, yes, Mr. Suraj Bhaskaran has answered half, okay. Some more answers, please. Some load up to 40%, okay. Okay, so let's see what happens in that case. Actually, in this case, the load capacity is 0 kilonewton, because we cannot assure that even if it is 99%, if the curing is not done completely, we cannot assure the load capacity. And you don't believe that. In most of the sites, people call that sometimes, saying that we have installed everything properly. And when we check how much time you have given for the curing, they will say we have given for 2 hours, where it's like 3 hours required, and they say that load is not getting what we considered. For sure, you will not be able, because you have to complete the 3 hours of curing time as per what the chemical has required. So make sure the curing time is complete as per required. Here is an interesting graph. As you see, it's epoxy mortar, FIS EM plus for epoxy and FIS V for vinyl ester. You can see the gelling time. You can see the time over here in minutes, and you can see the temperature. Since the Middle East region is having almost like 30 to 40 degrees Celsius, we can see how does the epoxy place over here. We have got only 7 minutes of gelling time, and we have got only 2 minutes of vinyl ester time. It means once you drill the hole, once you install your anchor, you have got only 7 minutes for epoxy to align. Before that, it should be aligned. At the same time, you have got 2 minutes for align in vinyl ester, and this is why always epoxy is the most common choice in Middle East. At the same time, what about the curing time? You can see again time in hours. We require 5 hours for curing in epoxy. At the same time, for vinyl ester, for this temperature, we require only half an hour. So in some cases, if the project is fast moving, or if you want to finish your job, if the load is not that what we consider, yes, even vinyl ester is also a good option. I hope gelling and curing time is clear. If you have any questions, please don't hesitate to have it in a question and answer session. At the end of session, we will answer all the questions. Now, moving to installation steps and accessories. Yes, that's true. Whenever you have an installation of a chemical, you can see different types of accessories used. It's not because that we need to use all the accessories. It's because the chemical that has been tested as per ETA was done with all these accessories. So there is importance in accessories that should be taken care when we are doing installation. Let's say for a drilling rebar application, we do require a drilling aid. It's just to avoid the cover so that we don't damage the cover of the concrete or reinforced structures, and also to make sure that you don't damage any reinforced rebar inside the structure. So we have to use a drilling aid. At the same time, cleaning, the next most important, and now everyone is aware that cleaning is one of the most important thing that has to be done when you're doing an installation. You can see a live picture where blowing is happening and brushing is also happening. At the same time, you can see the installation steps. These steps are available in our ETA of each product. That is why, again, approvals valid, because once you have this approval, all the installation steps, all the gelling time, curing time, what load you're looking will be there in that ETA. Now, moving for the injection of chemical, there are different types of dispenser. You can see manual dispenser, you can see pneumatic dispenser, and also battery operated dispenser. Each and all have its own good and bad. So still we have different types of dispenser. At the same time, you can see an extension tube. Let's assume your hole is higher than 500 mm. Your static mixer will not be able to reach the end. In this case, you have an extension tube which will be connected to the static mixer, and you can easily inject your chemical inside. So for injecting, you can see you require a static mixer, you require a dispenser, and etc. Here comes a curious question, which is like overhead application. Yes, there are cases where you require chemical for overhead application also. One of the best solutions is always capsule, because you can make sure that the capsule is being inserted properly inside the hole. At the same time, there are places where required more load or more, you have to go more depth. In that case, you can use the chemical, and when we use a chemical, there is a question arising. What happens when you use a chemical, the chemical comes out? To avoid that, you can use the wedges to make sure that the wedges are blocked here with the threaded rod and the chemical. So the chemical is not coming out, and you require to give the curing time as required for the chemical. For capsule installation, you have its own accessories so that the capsule breaks and fixed properly. It will be having a chisel, and it will be having a sharpened rod used so that capsule breaks inside the hole and the rod gets installed properly. Now, the last one for my session, which is known as drill hole conditions. As you all are aware about diamond core holes, what does a diamond core hole means? When you have a high strength concrete, we need to do a diamond core drilling. At the same time, if you have a bigger diameter where the normal hammer drilling cannot be used, you have to use this diamond core drilling. When you have a heavily reinforced structures, like you have reinforced bars packed closely, you need to use a structure so that it doesn't get defected. So first of all, the question is that, does the consultant know you are cutting all his rebars? Yes, for sure, the consultant should be aware that you are cutting the rebar, because the design of the structure and regular structure stands on the reinforcement, and he should be aware that yes, we are doing in core drill for some other applications. Is there any difference between a hammer drill and diamond core hole? Yes, there is difference. We'll come in the coming session. I'll show you what is the difference between a hammer drill and a diamond core hole. Do you think there should be special precautions or installation steps for diamond core holes? Yes, there are installation steps. You can have elaborated installation steps are shown in ETA, because there is a slight change in cleaning procedures, and also whether it have an influence in the load capacity. But for all this condition, we do have a solution which is known as epoxy mortar plus, which is known as FIS EM plus, which has got 120 years of service life. It's used in water application. It's used having all the approvals like seismic, fire, ICC, and all the approvals. At the same time, it has been approved for diamond core drilling as well as for hammer drilling. As said, in a software, if you have a design to do that, someone is asking, no, we need a design with diamond drilling. Yes, Fischer can provide you a solution showing that load capacity in CFix can be changed, where it's showing diamond drilling or hammer drilling. So if you have a diamond drilling, you just need to change the option and designs can be done. Here is the procedure of diamond drill core hole. The best part of the product, which I explained, like FIS EM plus, is that we don't require any other roughening apart from the drilling. So you don't need to do any extra roughening, because you know once you are doing diamond core drilling is going rotary and it will be a smooth surface. But this chemical has got approval without roughening. Let's watch a video. This is very interesting video, and once you watch this video, you will understand how important is a drill hole cleaning. So now I hope you guys understood why cleaning is so important. Where cleaning was properly done, it was about 24 kilonewton, whereas the cleaning was not done, it's only 6 kilonewton. It has come like 4 times down. So you can see the exact image also, like duff and floor over here in that chemical, because the cleaning was not done properly. And moving to next, my colleague, Mr. Omar Jazari, will be taking up the section. The stage is all yours.
Thank you very much, Dinesh. Hope the first 5 important factors that influencing the chemical anchor will be very clear for all of you. Moving on to the other important second 5 factor, we will speak about the concrete condition, the load and design, temperature, humidity, and the shelf life and storage. Let's start with the concrete condition. What about the concrete condition? As you know, the concrete as a material is very weak in tension and very strong in compression. So this is the reason why the structural engineer put reinforcement in the tension zone. If you see here, when the live load coming to the structure, this black line showing the tension zone. In this tension zone, the concrete, it will be crack. There is some crack with some width of this crack, it will appear to this concrete. Now, when you want to install the anchor at this zone, which is tension zone, which is a cracked concrete, you should be ensured that the anchor that you use is approved for a cracked concrete. And the other side, which is here, showing that the non-cracked concrete, which is compression zone. So this is the difference between a cracked and non-cracked. The European Technical Authority recommend that if you don't know that the concrete is a cracked or non-cracked, if you want to fix your anchor in a cracked in tension zone or compression zone, if you don't know, the European Technical Authority recommend that you should assume that you will fix in the cracked concrete, which is a critical case. And the tension in the tension zone, as you see, when the load is moving, it will be different. It will change the location of this tension zone during the changing of the load itself. Now, the European Technical Authority recommend there is procedure test you should follow. The supplier of the anchor, any anchor supplier should follow that this anchor is approved for a cracked concrete, especially for chemical. Like the crack width, they mention what is the crack width, what is the maximum crack width that you test your anchor under this one. And this crack width they use, they measure the movement. What is the movement of this anchor during the crack? For example, here, if the crack width is 0.3 millimeter, the displacement of the anchor, when you apply the tension load to the anchor itself, it reaches around 2.5 millimeter. This 2.5 millimeter is accepted based on the should be less than the limit value which is mentioned in the European Technical Authority or European Technical Assessment. For example, if you have the crack width, you test your anchor under a crack width 0.4 millimeter, the displacement should be 4.2 millimeter, should not exceed this one to be approved for cracked concrete. Now, the second thing we should focus in the concrete, the seismic. What about the seismic? We can divide the seismic category into 2 categories, C1 and C2. C2 is more dangerous C1. The main difference between the category 1 and category 2 is the crack width. The crack width in category 1, the anchor it is testing under a crack width 0.5 millimeter. While in the seismic performance category 2, the anchor is tested under a crack width which is around 0.8 millimeter. Now, this seismic will affect to the bond strength itself. How it will affect? If you see this paragraph in the static performance in cracked concrete, the bond strength is around 8 megapascal. When you test the anchor or the chemical anchor under seismic performance category 2, which is the crack width is around 0.8 millimeter, the bond strength is decreased to 5 megapascal. So the decreases of almost around 45% in the bond strength. So the ETA European technical assessment will test this anchor, and they give this approval for this anchor, and should be tested based on the recommended that's mentioned in the European Technical Authority. Moving on to the second important point, the load and design. What is the action load at the anchor? How we can ensure that this anchor can hold this load that acting on it. Before I start, I have one question. If you can write it in the chat box, please. What do you expect the failure mode of the tension when we have the anchor that inserted in the concrete, and we make the tension? What is the failure mode that happened? Where is the failure it will appear? Is it appear to the concrete or to the anchor, to the chemical itself? What do you expect? Anyone can help me, please? In concrete, usually the chemical. Actually, the concrete, the failure mode, maybe it can be combined. It can be in concrete itself or chemical, or combined concrete and chemical. One of the failure or the most failure mode that happen is the concrete cone failure. The concrete itself, when the concrete has tension load, there's the concrete it will serve as a cone shape. It will be extracted from the base material as a cone shape. So this is the first mode. The second mode is the splitting failure. Splitting failure, this happen when the concrete thickness is small or the anchorage depth is very high, is very long. So this is the second type of failure that coming from the tension load. The third one, the failure on the anchor itself, on the chemical itself. Sorry, not in the chemical, in the steel itself. The steel, the thread rod, the tension load exceeds the capacity of the steel itself. So this is the third one of the failure mode. The last one, the pull-out failure. The anchor doesn't have a proper adhesive bonding between the anchor and the chemical itself, and this is the what did the Danish say in the fifth factor, which is the cleaning. The cleaning should be made in a proper way to make the adhesive bonding very high quality between the anchor and the chemical, and between the chemical and the concrete itself. Now let's go to the failure mode in the shear. We have the steel failure. The second one is concrete breakout failure, or the concrete edge failure. And this is the important thing we should focus about it, the edge failure. Especially when you want to fix your anchor like curtain wall, any application that the anchor is very near to the edge of the concrete, you should consider this edge distance. Now, load and design. One thing I want to add in general, that the engineer should understand the calculation output by our software. There is Fischer software called Fixperience, which is famous software, and you can download it in the Fischer website. By this software, you can make calculation and you can check the anchor itself. Now, they should check the resulting anchor forces and not the design action when a pull-out test is conducted. We will see this one in the next slide. The second important point I want to focus about it, that the increasing immitment depth is not always the solution. Maybe the case or the anchor, it will fail if you increase the immitment depth because some other factor. Also, the increasing the diameter of the anchor also is not always the solution, because it will affected by other factors like concrete cone failure. So it is not always the solution to choose the bigger size or the longest embedment depth. Now, if we have this example, we have this base plate having the load that acting from the structure itself. This is the reaction that coming to the base plate. We have tension 1.5 kilonewton. We have this moment 2.5. We have this moment 2.5. Now the question is, the consultant needs to check if this anchor can hold the load or not. we will make pull-out test in the site. When we make the pull-out test, this value we should compare it with which value exactly, to 1.5 or which value. Actually, the software make finite element design and finite element analysis, and they distribute these forces to each anchor. These forces called 1.5, 2.5, 2.5. This force is called design action. From this design action by software, it will convert it to the resultant anchor forces. Each of one anchor will take only one tension or shear. For example, here number one anchor take a tensile force around 9.7 and shear 2.5 kilonewton. The maximum one between of these four anchors is 9.7. So the pull-out test or the pull-out that conducted in the site should exceed this one, the 9.7 kilonewton. This one comes from the report and that downloaded and extracted from the Fischer software experience. Now the second point, we have here, for example, this case, and we have the M16 anchor board with anchorage depth around 65 millimeter. And the utilization here is around 90%, 93%. If we increase the size, it will be fail. If we increase the size to 24, it will fail, because the concrete cone shape it will be overlapping with each anchor. So the capacity it will become down for the concrete cone especially, and the case it will be fail. So this is one example show that the increasing in diameter, it is not be always the solution. Now moving to the third important factor, which is the temperature. What about the temperature, in the high temperature, especially in the Middle East? We are facing many high temperature, like the temperature degree reach around 54 Celsius and more. So is this high temperature will affect what? Have you ever faced any challenges with chemical anchoring due to the heat? Sure, there are many challenges. The most important two is the curing is very fast. The curing is very fast, and the chemical should be stored in the cold place. There is a specific limit temperature you should store the chemical. Now, what about the long-term effects due to the high temperature? What is the effect of this temperature after long time? It will affect it to the bond strength itself, and this is show what is the quality of the chemical. Is this chemical from Fischer or from other brand that can hold or can save the same capacity during while the high temperature is coming? For example, here we have this anchor FISEM plus, the premium one, M12 threaded rod non-cracked concrete. For long-term temperature 35 Celsius, the bond strength is 18 megapascal. For long-time temperature 50 Celsius, it will be decreased. But you see here, the decrease is very slightly small. The decrease is almost around 5% in the bond strength, as you see here. One other example for thread rod M12 in cracked concrete, for 35 long-time temperature, the bond strength is 9 megapascal. For the 50 Celsius, is around 9 megapascal also. And this is very rare. You cannot find it in every supplier. Other competitor has in the high temperature, there is decrease between 8 megapascal to 6 megapascal. So this is the effect of high temperature. Now, what about in case of fire? What will happen for the fire case? If there is a decreased performance due to higher temperature, what will happen in case of fire? Sure, there is decrease of the performance of the fire. There is something called fire resistant should be tested for this chemical. And our chemical has R120 and R240 based on the chemical that you selection. The other thing you should about not the chemical itself, the thread rod and the steel connection, is it protected or no? And this is important thing. Maybe the failure, it will happen to the steel plate or to the steel structure or steel connection, not to the chemical. Now, this paragraph show in case of fire what happened to the steel itself, to the threaded rod itself. If the thread rod in static performance can hold around 180 kilonewton and 120 minutes fire, it will the load will be around 10 kilonewton, decrease to almost 6.9% of the design value. So this should be the focus about. Moving on to the fourth factor, which is important, the humidity. What is the drilling hole condition? What is the condition of the hole? Now we have a 3 condition hole: dry and wet, flooded drill hole, underwater application. Actually, these three stages of humidity will affect on the curing time. If you have a curing time in dry concrete, for example, 5 hours, you should double it in wet concrete. In wet concrete or water-filled hole, that the curing must be doubled. Installation in water-filled hole might be possible. However, the bond strength might be less than in a dry and wet hole. Wet or underwater application. ETA cover application in a dry and wet and water-filled hole. Application outside of ETA for underwater application. For this application, curing time have to be doubled. Also, our chemical FISEM Plus is tested for the NSFF. FISEM Plus is tested in drinking water system and has no harm to such. Thus, also does not harm to the sea creatures. We have here case study for in Dubai Harbor project. This ladder, it will fix it under the water. And it will fix it using the chemical FISEM Plus. If you see this one is scuba diver, he sink in the sea and he installed the anchor under the sea. And we make test for this anchor, and it reached around the double of the required design load. Moving to the last factor is the shelf life and the storage. What is the shelf life? What is the longest shelf life that the chemical can be stored? There is some important point we should mention about it. The chemical should always be stored in the cool and dry place between 5 Celsius to 3 Celsius. Within our shelf life, we also consider that the cooling chain might be interrupted for a maximum of 2 weeks total. Now, this is storage and shelf life for chemical FISEM Plus. We have the longest shelf life is around 36 months, 3 years. For FISEB, 36 months. For FISV, 18 months. Also for FISVL, the same thing, 18 months. For FISP polyester is 12 months. Also for our capsules, we have the longest shelf life is around 36 months, which is 2 years. Expired chemical should not be used. Fischer cannot make any statement regarding the performance of the chemical after the expired date. Now, this is the summary of our important chemical or our most top chemical. We can divide it into fast curing and low curing. In the fast curing, we have polyester and polyester. In low curing, we have the epoxy. Fast curing, if you have the best material masonry, the most economic solution, it will be FISB plus, but you should check the load itself. Has many advantages, ETA approved, best performance in masonry, no special requirement is required. Procurement cost can be reduced based on the polyester resin. Shelf life is around 15 months. If you want to reach the high level of the load more than FISB plus, you can go to FISBL. Also, you can fix this one in concrete and masonry. If ISBL is approved for ETA repair and masonry, allows for anchoring in water-filled drill hole. It has 50 years service life expectancy, and it is economic price, and the shelf life is around 18 months. And if you want to reach also more the load which is more than this BL, you can choose this B plus. You can fix it in the concrete and masonry. It has seismic approval. Also, it has 100 years service life expectancy. For the low curing time, which is epoxy base, we have the most important three product: FISEB, FISEB, and FISEM plus. FISEP, it is the cost-efficient epoxy mortar and the suitable for concrete and rebar application, and the shelf life is 36 months, but it has no approval. If you want approval, FSEB is the solution. It is the ETA approval and has the ICC approval, which is American one, and the highest temperature range for the epoxy mortar has 100-year service life expectancy, and approved underwater and under seawater application, and the shelf life is 36 months. The most premium one and the strongest chemical in the world is FISEM plus. FISEM plus has ETA approval, option 1 and option 2 for and seismic category C1 and C2. And service life is around 120 years expectancy, and it is approved underwater and under seawater application. And the shelf life is around 36 months. So this is the end of the presentation. Hope it's really clear for you. Thank you very much for your attention. Please, Mr. Danish, now your stage.
Thank you, Mr. Omar, for the great session. Now we'll move to the question and answer section. We have some questions already in our chat box. We request one and all to add your questions in question and answer. Below you can see Q&A section. You can just go there and type all your questions regarding the topic. First of all, we have a question from. First of all, we have the question from Mr. Suraj Bhaskar. Are there more expensive solutions other than chemical anchoring? That's a good question over here, but I would like to say that all the solutions which Fischer provides is first of all an economical solution. When you're comparing with a chemical anchoring with a mechanical anchoring, it depends case to case and also application wise, because in some cases, if you're going for higher dia of mechanical anchors, where it will be much expensive than that of a chemical anchoring. At the same time, you can provide the same solution with less embedment depth or with anchorage depth more, but with smaller size. So it depends to case to case. We cannot say that chemical anchoring is an expensive solution, but yes, we do say that we do provide economical solution as per the case. There is other question on the chat box by Mr. Teddy. Can you clean the drill hole using pipe water or blowing using air is the only option? Okay. Again, as we were discussing about different products, in Fischer, we do have some chemicals where we don't have a problem if you are using the pipe water or any water, because it's already approved to be used in underwater application. So yes, if you are using a forced high water, yes, you can use, and it will be more precise also, so that you make sure that it's clean and it's get dried. But make sure the chemical which you are using has a capability saying that it can be used in underwater or in water areas. Otherwise, it will have a bad effect. At the same time, yes, blowing using air, yes, that also is a most commonly used solutions all over the world with brushing. I hope those were the two questions. I think the session was quite interesting for you guys, and I hope you guys had a good learning on the session. Moving to the next slide, we have one most important thing which we require from your side. It's poll, because your opinion matters for us. We want to improve it like where we have, I mean, like, or in each section. So we request one and all participants to make sure that you give our feedback in this poll. Please make use of this poll. You can have your honest feedbacks so that next time we report all our mistakes and come back to you guys. It's just about 2 minutes. You can have everyone can have their own feedbacks. If you have any questions, don't hesitate. You can write right now also to the question and answer section. We will go and we will discuss. If you have any application or if you have anything required. Yes. Yes, we have a next question from Mr. Yes, we have a next question from Mr. Mohammed Obasid. He's asking, why is the installation using capsule cleaning is not required? First of all, mostly the capsule is required in the in the slab position, in your overhead applications. So once you drill it, make sure that the dust are coming out. At the same time, the capsules which Fischer has been tested has done the ETA, which I'm saying the third party approval without cleaning. And it was showing the performance because it gets mixed to that and it gets bonded over there. And that is why there's no requirement of chemical from Fischer capsule is not required. We request once again that if you have any questions, please don't hesitate. You can type, we will answer, or once even the session is over, we'll report back to you through email. And for more information regarding any topic on Fischer, yes, we are here to serve you. Myself again, Mr. Dinesh Ajay Kumar, Senior Field Engineer who is located in UAE, and my colleague, Mr. Omar Al Jazairi, Senior Field Engineer for KSA, who is situated in located in KSA. We are available for you by 24/7. At any time, you can have any queries, you can ask us. I hope the session was interactive, and I hope you guys had quite good learning about the 10 factors influencing in chemical. Once again, thank you to one and all who have been participated and who has given your time for this valuable section. So once again, thank you to all. Thank you so much.
Thank you very much for your attendance and hope it's very clear. Thank you.